Your mother may have told you that it's not polite to snoop around. And that's absolutely true. Except one exception, DHCP snooping. Let's take a look at this particular functionality in this nugget. DHCP snooping is so beloved because it's going to guard against two different things. It's going to guard against the spoofing of actual DHCP information that we want to lease out there. This is called rogue DHCP servers, and it's a key to like a man-in-the-middle attack. What the attacker will do is they'll give false default gateway information to the clients, and then the clients will start sending everything for off-net to that particular attacker. Also, think about exhaustion attacks. They're going to be prevented with DHCP snooping. This is where clients are flooding the actual DHCP device with bogus requests for information just to literally exhaust the mappings that that particular device can give out. As you can see, we're going to use the concept of trusted ports. These ports are going to be leading out to our trusted DHCP server. Everything else is untrusted by default, and this will make sure that only legitimate information makes it out to our clients. As you might guess, a common misconfiguration here is forgetting to go to all of the ports where the legitimate DHCP server is going to be sending in its information and making them trusted. Because remember, the default state is untrust. So here we have a practice lab topology, and let's go over to R3 and let's make it a legitimate DHCP server for our environment. So I'm going to go and on this device say IP DHCP pool, and we'll name our pool VLAN_100. We will give out the network space for our scenario, and we'll give the default gateway, which of course is done with the default router command. And we'll make R3 itself the default gateway for this particular environment. More realistically, it would be another device. Let's go ahead and make it R5 is our default gateway. All right, great. So let's end this configuration, and we'll just verify that I did that correctly by looking at the running configuration, and it just scrolled past. There it is. Perfect. So this is exactly what we want for our DHCP server. Now what we'll do is we'll go to R1 and R5, and we'll make them DHCP clients. So we'll go to R1. We'll go to its interface, and we'll say no IP address, get rid of the static assignment, and say IP address DHCP. All right, great. I'll go ahead and make this configuration on R5 as well, so you don't have to watch me do that again. All right, so I did that on R5 for us, and in fact, look what just happened. We see a status message that says we just got an address. We got 10.10.10.2 on R5. I'm assuming over on R1, let's check it out. We'll do show IP interface brief, and we can see that we got the 10.10.10.1 address. Okay, great. So DHCP is functioning perfectly in our environment. Now, of course, one thing that's pretty funny here is we didn't do a reservation for our default gateway address. So R5 got 10.10.10.2, and we have a default gateway that's being given to everyone in this scenario of 10.10.10.5. That doesn't actually exist in our scenario, but that's fine because we don't need that for testing purposes. But obviously, just pointing out a little review on proper DHCP implementation, you would go ahead and either statically configure your default gateway, the most likely scenario, or you would set up a reservation for that particular address. Okay, so now back to the point. We want to go to switch 3, and we want to set up DHCP snooping on this device. So let's go to switch 3. That would be line 9 here. And what we do to enable DHCP snooping is first we do it globally. So simple command, IP DHCP snooping in global configuration mode. Then don't forget, you need to turn this feature on for the VLANs where you want it to be active. It is now functioning. If we end this configuration and we go over to, let's say, R1, and we go to the interface and shut it down that is being serviced by DHCP, and then no shut it, we're going to see that it fails to receive a DHCP address. So we're going to do show IP interface brief, and we're going to see it's supposed to be utilizing DHCP, but we are not going to get an address. We can sit here forever. What's going on? Well, you know. Fast Ethernet 0/3 leading out to our DHCP server is untrusted. So sure enough, we are in a situation here where the R3 device is looked at as rogue. Rogue Nation. I think that was a movie. Maybe even starring Tom Cruise. I don't know. Anyways, so over on switch 3, we've got some more work to do, don't we? Sure, we need to go to the interface Fast Ethernet 0/3, and we need to make this interface trusted. Very simple to do. IP, DHCP, snooping, trust. There we go. Now we have a trusted interface for the interface that leads out to our legitimate DHCP server. But there's another configuration that we need to make that would be really tough for you to catch if you didn't know about it. So please take note of this. When we turn on DHCP snooping, there's an option 82 field that Cisco starts injecting on these snooping devices, and they leave this field blank. This is used for additional information with DHCP relay, and the Cisco DHCP server that we have, R3, will reject those messages. So all we got to do to fix this, it's no big deal, is say no IP DHCP snooping information option. This refers to option 82. So it does not manipulate this information and won't cause us a problem with the Cisco DHCP server here. So let's do this. Let's review the full configuration for IP DHCP snooping here on switch 3. So we'll just do a show run and we'll take it from the top. We have IP DHCP snooping to globally enable the feature. Then we turn it on for VLAN 100. Then we remember to take care of that information option that could mess us up with a Cisco DHCP server, and that's no IP DHCP snooping information option. Then what we did was we went under the Fast Ethernet 0/3 interface, which leads out to our trusted DHCP server, and we make that port trusted. That's it. That's the only configuration that we make here regarding DHCP snooping. Now, is it working? Is it working? A great way to immediately see if we've had success is to do a show IP DHCP snooping and take a look at the binding database on this particular device, and we see it is working. It's mapping the MAC address to the IP address to the particular port for our DHCP clients. And we're actually going to leverage this database with other security features in other nuggets. How cool is that? Yeah, if we have all of this information about the client, then can't we stop like MAC address spoofing and IP address spoofing? Of course we can. Now, when you're troubleshooting this, what you would want to do when you're troubleshooting your DHCP snooping configuration, what you would want to do is go to R1, for instance, go to one of your clients. Whoops. Let's make a connection to R1, clear line 41, and then go to R1. So what you would do is you would debug DHCP detail. This is the debugging that you would do on a client. And of course, you would come over and you would go to your interface and you would shut it. And this will allow you to see the surrendering of the DHCP information. And then, as a matter of fact, you could go over to your DHCP snooping device and you could go ahead and clear IP DHCP snooping binding. And then we'll show that once again. And we see that the bindings are cleared. And we should get a new entry in for the R5 device. So that's eventually going to happen. But with the R1 device, we have the interface in the shutdown state, so it's not coming back. So notice we can kind of trace this with debug. So we go back over to the R1 device. And here on the R1 device, we know DHCP has surrendered its information. We'll no shut that particular interface. And now we can watch the DHCP process on this client. So it's failed initially, and then it's sending another discover. This will take some time, especially with our DHCP snooping process involved. But we'll see, and we can watch here on R1 as it retries to get its DHCP address. That didn't work. And then eventually we'll see the success. We can literally watch this process and bang, there it is. We can see, let me scroll up here. We see that we did indeed get a new lease information, and we can see the details of that particular transaction. The lease server is 10.10.10.3. That's the R3 device, just as we would suspect. We can see the requested IP address that we asked for thanks to the offer of 10.10.10.10, and we eventually get that particular address. Again, we can go back to our switch. We can look at the binding table, and we see we have the binding there for the R1 client. The what's going on with the R5 client? Well, it had its DHCP server address, and it's not going to renew it for some time. And then, of course, once it renews it, it'll show up here in the binding database. We could go out and force that with a shut, no shut. But I just wanted to show you the debugging that we can do there out at the client when you're troubleshooting this configuration. We could also go to R3. Let's see, the R3 device. Let's go to that device. And what you could do on the DHCP server itself from a debug perspective is you could do debug IP DHCP server, and you could see events, and you could also debug packet information for those messages. So pretty cool. We have commands that we can use on both the client and the DHCP server, as well as the DHCP snooping device itself, to really troubleshoot this fairly complex configuration, especially when compared to some of the other security configurations that we've looked at. And by the way, in the background, I just went over to R1 and I shut and no shut its interface. So you could see some examples of some of the great server-side DHCP debugging information that we will receive. Now, with our configuration, did we really fully protect VLAN 1 from these types of DHCP server attacks? And the answer is no, not fully. Yeah. We went and we configured our DHCP snooping here on switch 3. But Switch 1 certainly incorporates VLAN 100, so we would want to make the same configuration over on switch 1. So we'd enable DHCP snooping globally, we'd set it up for VLAN 1, and we'd take care of the information option. So that would be negating the DHCP snooping information option. And then we would want to configure our trusted port. Now, we know that our DHCP server is right here. So what port on switch 1 would be the trusted port? You got it. It would be Fast Ethernet 0/16, the trunk port that is going to be receiving the respectable DHCP server traffic in our environment. So I won't bore you with that redundant configuration, but we would want to make it on switch 1 to fully protect our VLAN 100 in our infrastructure. So in this nugget, we dissected the DHCP snooping feature, which is dissecting our network in trusted and untrusted ports in order to guard against a variety of DHCP-related attacks. Remember, this feature is going to feed some additional security features that we're going to examine. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.